Let's start with the problem maximum sum subarray in circular. So you might have already dealt with a similar problem, but this time we have a little modification that we have to find maximum sum subarray, but it could be circular as well. Okay, what does the question say here? The question is saying given an array of integers ARR in a circular fashion, find the maximum subarray sum that we can get if we assume the array to be circular. The question is same, just there is one more thing that we need to consider the circular subarrays as well. Now in this question, if we see, now here you can see we are considering this subarray beginning from here and ending here. So this is the subarray if you want to see it in this manner. It is beginning from here and ending till here. All of the elements from 7 till -1 are considered, but one more element, which is this one, is considered. So now in this case, the output is 23. You can see it this way. And then we have one more case here in which we have our subarray beginning from this point and going till this. So we have to take under consideration that we can get like answers possibly from both the types. It could be a normal subarray or it could be a circular subarray. That's all. Our very first approach, the basic one. How can we get it? Well, if we just go with the brute force and we try out every solution possible, that means every subarray possible, we can get the answer from there, right? How? Let's see. Assume we are beginning up with this 8. So we need to say, okay, 8 is a subarray, then 8 and -8 is a subarray, 8, -8, and 9 is a subarray, and so on and so forth. We are going to make all of these subarrays, right? One iteration done. That means now we need to move ahead to the next value, this one, -8. So all these subarrays beginning with -8. The subarray is going to be this, 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 and this. Now here comes the circular part. We are going to consider one more subarray, the circular subarray, which ends at 12, which goes like from this point till 12 and ends at 8. Okay, this is also a condition that we need to keep in mind. And from here onwards, every value that we are going to take up, let's suppose we start with 9 here. So all of these possible subarrays are going to be there, but the last subarray would be including these two values from front as well. Okay, so we need to check up each and every possibility, and we need to find out that, okay, if we encounter like we are finding sum of all, we are keeping the track of which sum is maximum. Eventually, once all of the subarrays are exhausted, including the circular ones, we can get the result as the maximum sum subarray. Okay, let's see the code for it and it'll get more clearer to you. Okay, so here is the code for it. What are we doing here? We have our value n, keeping the track of the length. Then I have made one variable result, which will keep the maximum sum subarray by the end of this traversal. Okay, initially I'm putting the first value here. Now I'm running my I, that means each and every time I'm choosing one ith value, and from that we are choosing that, okay, beginning with this one, what are all of the possible subarrays, right? Here, current sum for this particular ith, I've marked it as 0. Now J is making all the possible combinations. What are we doing? We are doing the index like I plus j modulo n. Why are we doing so? Because we need to take into consideration that if my elements are exhausted in the array, we make sure that we are considering the ones which are in the beginning. So now circular sum plus array index, we are just like keeping the count, not actually the count, but the sum. We keep on adding the sum for every subarray, and then we compare, we maximize that whatsoever result we have and whatsoever current sum that we have calculated for every next subarray, we are going to maximize the result accordingly. Now once we are done with both of these loops and all of the possibilities are done, we can return the result from here. Now this approach, although it is right, but it takes a lot of time. You can see that your I is going to run for n times, and for every time your j is also going to run for n times. Not even from I till j, not even from I till n minus 1. It is going to go for I till the next I minus 1th element that you have, because we are keeping a check of that here. Okay, so every time this is going to be the situation. Thus the time complexity of this approach is going to turn out to be order of n square, right? Are we consuming any extra space? No, we are not consuming any extra space. Thus order of 1 is going to be the space complexity of it. And obviously we do need to improve this. So let's see how we can improve this. Well, before even moving ahead to this approach too, one thing I would want to tell you is, like, we have two situations. First of all, that we can find up our maximum subarray in the normal situation, or we may find our maximum subarray in the circular situation. Both are the possibilities. So why not, like, we already know how to calculate the normal maximum subarray, right? Basic Cadane's algorithm. Let me give you a little revision of that. What do we do in that? We iterate through all the elements. My eye just travels from the beginning, 0th element, to the first element, considering how we are forming up our loop. Okay, so here what are we going to do? We are going to have a result variable, and we will have one sum. So every time we are going to calculate the sum, we are going to maximize the result. How? Let's see. Let's suppose I have this element I. Now initially I would have included that in my sum because I am considering the first element. That is going to be the minimum, like this one element is going to be the minimum possibility of your subarray, right? Then you keep on adding the elements, right? And every time you see whether the sum you are adding up, that means your sum plus ARRI, if this is giving you the bigger value, that means if this value is included in the sum, if this is the bigger value, or this value independently is the bigger value. Okay, we are considering all the elements ending with our ith value. Okay, if that is bigger, then we consider that, or we consider the ith value only and we proceed a new subarray with it. Okay, this is how we do it, correct? So once we are done with that, we know that we can easily calculate our normal subarray sum. Now the thing is, how are we going to calculate the circular subarray sum? For that, you might already be aware about prefix and suffix, right? In which we consider some trick, or you can say some step that we will follow for all the prefix subarrays or for all the suffix subarrays. So in this, what I will do is, let's name this array as maximum suffix and start calculating the suffix. Okay, here. So the last value will be copied, right? This one is negative. And now what are we going to do is, we are going to check that, okay, what is the summation here? Well, here 12 plus minus 11, it will be 1. Now what is bigger? 1 is bigger or 12 is bigger? The value already. Okay, 12 is bigger, 12 will be kept here. Now moving ahead in the same direction, I have 1. So 1 plus 10, it will turn out to be 11. So what is bigger, 11 or 12? 12 is bigger, 12 would be kept. What is this signifying actually? Well, it is saying that from this point onwards, which subarray would you choose which would have a maximum sum? So for every turn, if you're going to choose this one, or this one, this 12, the value 12 that you have, the sum that you have, is going to be the maximum. Okay, let's keep on making a suffix array. So far the value was 11, so 11, negative 9. Now what do we have? We have 2 here. Which is bigger, 2 or 12? 12 is bigger, 12 would be written here. Again, coming here, I have 9 plus 2, that would turn out to be 11. Which value is bigger, 11 or 12? 12 is still bigger. We are going to keep on considering this value. Then I have 11 and negative 8. We would have 3. Now here, 3 or 12, which is bigger? Obviously 12 is bigger, so 12 would be kept here as well. Now again, adding up this value, 8, 9, 10, 11, we would have 11, and 11 and 12 is still 12 is bigger. In this particular case, we started with 12 and that value didn't change because that was the maximum one. But there could be a scenario that you encounter a bigger value here. Assume if here, like, instead of 8, or let me change any value in middle and tell you. Let's suppose instead of this negative 9, we had plus 9. Then it would be 11 plus 9. It would go to 20. Now, what will be the bigger value? 20 or 12? Then it would have been 12. So we would say that from this point onwards, if you have to choose a maximum subarray that includes that is valid from this point till the end, you can choose this array. Okay, this subarray including all of these values, because its value is bigger than any so far. Now that we have understood that, let's keep on sticking to the example that we have of negative 9. It would be 2. Now that we have made a suffix, it is telling that in this direction, in the suffix direction, what is the maximum sum subarray that we have? We have to do the same thing for prefixes. Now, once we have the suffix and once we have the prefix, at every ith possibility, I'm taking the maximum prefix and the maximum suffix. I can add just both of these and I would get the circular subarray. Let's see how are we doing that. Let's just start considering this element and start calculating the prefixes. Okay, let me raise up all of these values. Work of suffix is done. Now we are going to take help of this suffix, the maximum suffix array. Let's just start calculating. So initially I have 8. Okay, so far if we consider this subarray, I have this prefix sum as 8. What is the suffix sum? If we consider from here, what could be the maximum sum subarray possible in this direction, in the suffix direction? Well, we have to check the I plus 1th value, this one. So for here we have 12. So we can only take this possibility if we are going for maximum. All right. Now that we have done that, let's see what will we get here. Well, for us, if we consider this possibility, we would have 8 plus 12. That means we would have 20. Let's call it as circular result. Okay. We have calculated it as 20. Now I'm going to see every possibility with prefix and suffix. And here I will check that if I get any bigger value than 20, I would replace it simply. Now let's just start growing our prefix. Now here it would be 8 and negative 8. That means 0. If you're considering the array so far, then the prefix would be 0, but the next suffix would be 12, maximum suffix that we can consider. So it would be 0 plus 12. Again, it is not going to change because 12 is less than 20. No worries. Let's include one more value. We included 9, 0 plus 9. Now I have the prefix as 9 and the suffix as 12. 9 plus 12. What happened here? We got a value which is bigger than this. We got 21. So now this is going to be overwritten. Again, continuing the situation, 9 and negative 9, we got 0. 0 plus 12, this is the ith value. Checking the ith prefix and I plus 1th maximum suffix that we have stored. Okay, do we get any value? We don't, because like we get 12, but that is not bigger than 12, than 21. Then going to here at 10. Now if I do 10 plus this value 12, I get 22, which is bigger than this one. I would replace it, and then I would again include negative 1 and this negative 11, which would make my prefix negative 1. Now my answer is negative 1 plus 12, resulting in 11. It is not bigger than that. So this is going to be predominantly considered. Here, once I'm done with it, okay, let's take this value. Here, if I calculate the prefix, I can say negative 1 and 12. I only got 11 again, right? So we are not going to consider that because the prefix, like this complete array, is not giving you the maximum, correct? So from the circular response, or you can say from the circular result, we have got the maximum to be 12, in which we were considering this array here till 10, and the last value was being included in this manner. And let's take a closer look at this example again. Here we can get this array in these many, including this 12. I actually kind of missed it, right? But this was here. That means we are considering the circular fashion in the first one as well. I think I'd like really think that I've missed it previously, but now you know that 12 is also written here, correct? So this is a circular subarray which is leading us to the maximum value. Now in this case, you can see, you can find out the circular subarray, you can find out the normal maximum subarray too. But what will happen eventually once you are done calculating both of those, you just need to see which is the maximum. Is the normal maximum or is the circular result maximum? You will keep the maximum of both and then you can return that as the answer. Okay, quite simple. Let's try to analyze the complexity of it. What are we doing? First of all, we are moving in two directions. First one is this, left to right. Another one is this, right to left. First of all, we calculated the suffix. For that, we took order of n. Then after that, we calculated the prefix. For that, we took order of n. Just in the same same loop, I can also perform my normal cadence algorithm because I do have to keep track of that, right? So in this order of n only, this normal cadence would also be included because we are traveling in the same direction. And once that is done, we can eventually say we are not taking any time more than order of n. But are we taking any extra space here? Well, this time we are taking this maximum suffix array. Thus, the space complexity also going to be order of n this time. Let's see the code for the same. So here I have this variable n keeping the track of the length of my array. Then I have made this suffix sum initializing with the last value, as I've already told you in the diagram. Then I would have this array made of maximum suffix, which would be initially marked as zeros all, like this. And the last value will be copied. the way I copied 12. And then what are we doing using this loop? We are calculating the suffix sum and we are keeping the maximum value that has occurred so far. See, we are keeping on our suffix sum and we are only keeping the maximum value of these two, either the suffix sum which has been calculated or the previous value that I have. For this ith value, I have to judge whether the suffix sum that I've calculated is that bigger or the I plus 1th value that I have here is that is bigger. In our case, we knew we had 12 copied because this value was -11 and it was giving us 1 as the answer. Okay, so we only kept this maximum value and we have to keep on filling our suffix sum array. We have seen in the diagram how we do that, and this loop would be responsible for that. One part of the question is done. That means we have calculated the suffix. Now we have to move ahead to the prefix. Here I have circular sum that I have created. This will be keeping the track of my circular sum. And then I've also created a variable normal sum. Okay, we will take help of Cadane's algorithm and we would do this one. Okay, initializing both of the values with the first value that I have, the 0th value that I have. Now two variables are helping me out in current sum and prefix. The motive of both of these variables is going to be similar. We are going to be keeping the track of the summations, but prefix, this current sum would be helping us in the Cadane's algorithm, and prefix sum would be helping us in creating the prefix situation, okay, and calculating the circular sum. So here, first of all, I've simply performed the Cadane's algorithm. I'm saying current sum equals maximum of current sum plus the ith value that we are including. If this is a bigger value, or the ith value itself is a bigger value, whatsoever is that, we are going to consider that in the current sum, and we would calculate a normal sum by maximizing these two values, the normal sum and the current sum. Now once we are done with that, we will calculate the prefix. I would keep on adding the elements in the prefix one, and in the circular sum, I need to keep on maximizing the circular sum variable that I have. Plus, what are we doing? We are calculating the circular sum from the prefix and suffix here. The prefix that I've calculated for the ith plus whatsoever the maximum suffix value that my I plus 1th index is having, that would be considered. Now once I've calculated that and maximized this as well, after this loop has run completely, we would have two values. First one would be circular sum, another one would be normal sum. Now after the execution, we need to return the maximum of these two, whichsoever is bigger, because you have already seen the possibility that we can either get our answer simply in the normal subarray, or we could get our answer in the subarray of type circular. So this is what we have done here. This code, you can say order of n for this loop, order of n for this loop. Eventually it is going to be ending up as order of n, right? In the terms of time complexity, space complexity would be order of n, because we are using up this maximum suffix array. Okay, quite simple. Now that we have seen this approach and you have also understood the code, well, you must see that we are using this extra space. Could we try to reduce that with any additional logic? Could we try to avoid this extra space? Well, approach third is based on a certain observation. Let's discuss that. So we already know that we need to calculate two things. First is the normal sum, right? Another one is the circular sum. Now, once you're calculating the circular sum, let me give you any hypothetical situation that, let's say, this value was my maximum sum subarray. Now, suppose the maximum sum that you have created, the summation of this one comes out to be A. What will be the total sum? Let's consider that as S, the total sum. Okay, the total sum of all the elements of the array. Now, if we do something like this, S equals A plus this leftover sum, the leftover values that we have. This, let's consider that as B. So we can get this, right? S would be the summation of the A circular subarray that you have considered and the B leftover values that you have. Now this itself is also subarray. See that. Now tell me, if we are saying that A is the maximum value, won't B be the minimum value? How? Let's see. Suppose you have your value A, which you are considering as maximum, and you have your value B, but you doubt that B could not be maximum. Could not be minimum. Then you tell me, if there is any variation, if we try to reduce the value of B, then we must increase the value of A to keep the S same, right? Because we cannot just keep on decreasing the value of B and we can have S as same, right? S is dependent upon two variables, A and B. If B decreases, then A needs to increase to balance it out so that we have the complete sum as S. But if we are saying that A is already the peak, A is the maximum, then can we reduce the value of B? We cannot, signifying that B is the minimum subarray. So from this, we can conclude that my circular subarray is nothing but if we have the total sum minus the minimum sum, the minimum subarray sum. If we calculate that, we can calculate the circular sum. So I hope now you have got this like this simple thing here, because this is going to make our work so much easier. We know that we have a normal sum. We can calculate it using Cadaine's algorithm. Now we also know how can we calculate a circular sum without actually considering the circular situations, but by considering the minimum sum subarrays. The question arises, how can we find minimum sum subarrays? Well, it's pretty simple if you already know the Cadaine's approach to find the maximum sum subarray, because in that we were maximizing our choices, right? If we had, let's say, let's call it maximum sum, we had maximum of either maximum sum plus the ith value or the ith value itself. This is what we were doing, right? So if we have to calculate the minimum sum, can't we do minimum of both minimum sum when the ith value is included or the ith value independently? So we know how to do that in Cadaine's format. In the Cadaine's format too, we can also find out the minimum sum subarray. So now we are in the situation that we know what do we have to do. We have to calculate the normal sum. Then we have to calculate with the normal approach, we need to calculate the minimum sum using Cadaine's only. Once we have the minimum sum, then we are going to subtract it with the total sum to get our circular. After that, once you have achieved both your circular sum and normal sum, then you know what you have to do. Whichsoever is bigger, you need to return that. I hope this thing is clear to you. Now, once this is clear to you, there is one corner case which will be left. What? Let's see. Let's consider this array. Now here, like we know just by seeing that in such situation, the biggest value that I have is going to be the maximum sum subarray, in our case, -1. And you can find this with Cadaine's approach. But if you try to implement this logic that we are implementing here, so what you will do is you will find the minimum sum subarray. What will be the minimum sum subarray? In this case, it would be -1 plus -2 plus -3, ending up at -6, right? This would be a minimum. Now, if you try to see what is the total would be -6 too. Now, in such cases, if you try to find out your circular subarray, that would result in 0, because what you would do is you would take up your -6 as the total sum that you have, and then you would do minus the minimum sum that you have calculated. That would turn out to be -6 plus 6, and that would give you answer 0. Now you cannot have any subarray here which would sum to be 0. So this is a corner case. We need to see that whenever my total sum and my minimum sum is getting the same, then we need to simply return the normal answer that we have found, the normal subarray sum answer that we have found using Cadaine's. I hope all of this thing is clear to you. All of this algorithm that I've discussed with you, that is clear. Now let's move ahead and try to see the code for this approach so that everything could be clear in your head. So here, what are we doing? We are taking up our total sum, we are taking up our circular max sum, we are taking up our circular minimum sum, and we are taking up these two arrays, maximum sum, these two variables, maximum sum and minimum sum. For ARR0 and ARR0, this will help us in calculating it further. We are using one single loop here. This one is to calculate our maximum sum subarray, just normally like we do. This one is leading us to the minimum sum subarray. You can see we have just made little changes. Okay, we are taking up the current minimum sum instead of the current maximum sum, and we are putting up it in this variable. So eventually my maximum sum and my minimum sum, once these two are executed completely, we would have like the maximum and the minimum sum stored. Then I'm also calculating the total sum because that is going to come into handy once we calculate a circular sum. Once the loop is executed and we have done the traversal completely, then what do we need to do? We need to see here. Normal sum equals maximum sum. We know that. Circular sum equals total sum minus minimum sum. Now, once that is done, what do we need to do? We need to check whether my minimum sum and total sum are equal. If those are equal, then for sure the normal answer that we have used, that we have calculated using cadence, that is going to be returned. But if that is not the case, then then naturally we need to return either the normal sum or the circular sum. That means the maximum of both. Now, I hope this code is also clear to you. Let's do one more thing. Let's try to dry run that in the same example that we have taken. Okay, let's consider this one. All right. First, let's simply apply the cadence algorithm and let's try to find the maximum sum according to the cadence algorithm. Let's start making it up. We have 8. Now adding -8 to it. Which one is bigger? Adding it, we would get 0. 8 individually is bigger or this value is bigger? Well, we know that this value would be bigger, right? So we would carry it on. Now here, because I have encountered 8 before, 8 would be kept. Now let's start calculating. 0 plus 9. What do we have? We have 9. Which is bigger? 9 or 9? Either can be kept. It is bigger than the maximum ending. That would be considered. Again, adding these two values, 9 plus -9. Which one is bigger? -9 individually or 0? 0 is bigger. Fine. We kept that. Now going ahead, 0 plus 10. Which is bigger? 10 or 10? We can consider either. We have 10. Now we can see I've encountered a bigger value. Maximum ending would be updated. Now 10 and -11. Which value would be bigger? The addition, which would result in -1 or -11? Well, the addition value, this -1. Again, doing the same thing, -1 and 12, which is bigger? 12 itself is bigger or the -1 is bigger? Well, this time 12 itself is, sorry, not -1, but 11 is bigger. Once you perform 12 minus 1, it would give you 11. So which is bigger, 11 or 12? So here we are going to consider a new subarray from here. So we can say 12 is bigger. Now I have encountered a new value 12. So according to our normal cadence implementation, 12 is going to be my answer. Normal sum. Now other ways, what do we need to do? We need to calculate the minimum sum subarray. How will we do that? Let's see. Let's start calculating the minimum ending, or you can say the minimum sum in total using cadence. Considering the first value, okay, the first value is kept. Adding these two values, which one will be bigger? 8, or which one will be smaller this time? 8, -8, we have 0. So 0 or -8, which one is bigger? -8 is bigger. So -8 would be considered. I encountered a smaller value. Okay, I made it. -8 plus 9. What will it be? It will be 1, which is a smaller. 1 or 9 itself. 1 is a smaller, so 1 would be considered. Now 1 and -9. 1 and -9, we got -8. So what is bigger? What is the smaller? -9 or -8? Well, this time -9. So we are going to consider -9. Now we encountered one more value, one more smaller value. I'm going to keep this here. Again, carrying on the same thing, -9 plus 10. It comes out to be 1, which is smaller. 1 or 10? 1. 1 would be considered. And then 1 and -11. What will be the answer? The answer would be -10. Which is smaller, -10 or -11? -11 is smaller. You would consider -11, and you've encountered one more value here. Now that you have your 12, -11 plus 12, you would have answer 1, which is smaller. 1 or 12? 1 is smaller. We would keep that, but we have like the minimum value that we have calculated is -11 only, right? Now let's try to calculate the complete sum. What will be the complete sum here? Here we will have 8 and -8. This cancelled, this cancelled. We would be 10, this and this. So I got 22 minus 11. It will be your 11, right? This would be your maximum sum. Not maximum sum, but this would be your total sum. Now you have your total sum, you have your minimum sum. Let me write down here. The total sum is here, which is 11. Then your minimum sum is here, which is also your -11. Now if you have to calculate the circular sum, what will you do? You will take your total sum and you would subtract this value, minimum sum value. Here, what will it be? It will be 11 plus 11, and the answer would be 22. Now we need to consider these two values, normal sum and circular sum. Which one is bigger? Circular sum is bigger. We are going to return this as the main answer. We already saw that it is not giving us a situation when all the values are negative, such as this one. This is a corner case. We are dealing it here. We are seeing that if the minimum sum that we have calculated is equal to the total sum that we are calculating. If that is the case, we are going to return the normal sum because we know that normal cadena implementation would be giving me the maximum sum subarray. Now, I hope you have understood this approach very clearly because these little things could be a little confusing, but again, you need to dry run it yourself with any of the example that you want to form, and then you can lead to better understanding of this approach. Let's try to also discuss the time complexity of this. Well, what are we doing? We are just running an array once from initial point till the ending point. That means we are taking order of n time complexity, right? And are we using any extra loop? No, we are not. Are we using any nested loops? No, we are not, right? So that means this order of n is going to be the time complexity for this code. And talking about the space complexity, well, this time we have improved. We are not using any extra space. We are just using a few variables. The space complexity for this approach is going to be order of 1. This out of all three, this one is the best approach to work with. Let's try to run the code and see if it is passing all of the test cases. So here's the same code. Let's try to compile and run it. Okay, so you can see you are getting the expected output here. Let's try to submit this problem. Okay, so it has passed all of the test cases. So yeah, now I hope you have liked the solution and you have understood the problem as well. So make sure if you like this approach, you like the video and you tell me in the comments. Thank you.